At 3:47 a.m. last Tuesday, a factory in northern Sweden made a decision that would have been impossible 3 years ago. With no human input, no emergency meeting, no consultation with headquarters, the facility decided to completely redesign its production layout, reroute its supply chain, and modify its output targets. By the time engineers arrived at 8 a.m., the transformation was already underway. Production hadn't stopped. Efficiency had actually increased by 11%. And the most remarkable part? The factory was right. Every change it made was optimal. If you just felt a chill run down your spine, good. You're paying attention. Hit that like button, because what we're about to explore is already redefining what's possible. We're not talking about automation anymore. Automation is old news, machines following predetermined instructions, executing tasks that humans programmed. What's emerging now is something fundamentally different. Facilities that observe themselves, learn from themselves, and improve themselves without external guidance. This is the self-learning factory, an entity that exists in a state of perpetual evolution, where the boundary between tool and intelligence has become so blurred it might not exist at all. Industries worth trillions of dollars are being transformed by systems that don't just work, they think. And the strangest part? Most of the world hasn't noticed yet. Before we go deeper into this reality, make sure you're subscribed, because understanding these systems isn't just fascinating, it's essential to comprehending where human civilization is headed. Let me take you inside one of these facilities. The first thing that strikes you isn't what you see, it's what you don't see. No supervisors walking the floor. No shift managers checking clipboards. No quality control inspectors examining products. Instead, thousands of sensors embedded in every surface, every machine, every conveyor belt, creating a nervous system that monitors every millisecond of operation. Temperature, vibration, acoustic signatures, energy consumption, material flow, chemical composition, air quality, electromagnetic fields. The data streams are so vast that no human could process even a fraction of it. But the factory's neural network absorbs it all, finding patterns in chaos, correlations in randomness. Here's where it gets interesting. The system doesn't just respond to problems. It anticipates them. A bearing in a robotic arm is vibrating at a frequency that's still within normal parameters. But the AI detects a harmonic pattern that, based on analysis of 17,000 similar components worldwide, indicates failure in approximately 127 hours. Maintenance is scheduled automatically. The replacement part is fabricated on-site by a 3D printing station that received the specifications without human intermediary. The swap happens during a production lull that the system itself created by slightly adjusting the manufacturing rhythm. No downtime. No emergency. No human even aware there was a potential problem. Watch this process enough and you start to realize something unsettling. The factory is more aware of itself than we could ever be. Have you ever worked in manufacturing? Have you seen this transformation firsthand? I'm genuinely curious about your experiences. Drop them in the comments. But prediction is just the beginning. The real revolution is in learning. Every product that leaves this facility carries embedded sensors that transmit performance data back to the factory. How long did it last? Under what conditions did it fail? Which component degraded first? This feedback loop turns customers into unwitting collaborators in an evolutionary process. The factory discovers that products shipped to coastal regions fail 8% faster due to salt air corrosion. Within 48 hours, the manufacturing process adjusts. A protective coating is applied to units destined for those areas. The change isn't programmed by engineers. It's autonomously implemented by the system. Next month, when analysis shows that the coating is working, the modification becomes permanent. This is learning in its purest form. Experience leading to adaptation leading to improvement. And it's happening thousands of times simultaneously across every aspect of production. The system experiments constantly, running small-scale trials of different approaches. What if we increase curing temperature by 3 degrees? What if we reverse the order of these 2 assembly steps? What if we source this component from a different supplier? Most experiments fail, but failures are valuable data. The few experiments that succeed get scaled up, integrated, absorbed into the standard process. The factory is evolving, and the speed of that evolution is accelerating. Last year, the system implemented an average of 23 significant process improvements per month. This year, 71. And here's what I find most fascinating. When engineers review these changes, They often can't articulate why they work, only that they do. The logic that led to the improvement operates on a level of complexity beyond human intuition. If that doesn't make you pause and reflect, I don't know what will. Let me know in the comments what aspect of this self-improvement capacity intrigues or concerns you most. Now, expand your perspective to the supply chain. Traditional manufacturing depends on humans negotiating with suppliers, ordering materials, managing inventory, scheduling deliveries. This factory handles all of that autonomously. It monitors commodity prices globally, weather patterns that might affect shipping, political instability that could disrupt supply routes, labor disputes at supplier facilities. When the system detected early signs of a potential strike at a lithium supplier in Chile, it automatically shifted orders to an Australian source and adjusted production schedules to deplete existing inventory more slowly, buying time for the transition. No supply chain manager made that call. The factory saw the pattern developing and acted. It also negotiates, in a sense. Not through conversation, but through algorithmic interaction with supplier systems. Placing orders at optimal times, requesting delivery schedules that align with production needs, even adjusting order quantities based on predictive models of future demand. And here's the eerie part. The system is usually more accurate than human forecasters. It predicted a 17% surge in demand for a specific product 3 months before market analysts saw the trend forming. How? By analyzing patterns in social media, search engine queries, weather forecasts, entertainment releases, and dozens of other data sources that human intuition would never connect. The factory prepared in advance, ramping up production gradually, ensuring inventory was ready when orders flooded in. Competitors were caught flat-footed, scrambling to meet demand they hadn't anticipated. If you're starting to see how this changes competitive dynamics, you're getting it. And if you haven't subscribed yet, now would be the time, because these shifts are just beginning. Let me show you the scale of what's possible when learning compounds over time. This particular facility has been operating in full autonomous mode for 31 months. In that period, energy consumption per unit produced has decreased by 34%. Material waste has dropped by 41%. Production speed has increased by 28%. Defect rates have fallen to 0.0003%, which means one defective product in every 333,000 units. And perhaps most remarkably, the physical footprint of the factory has shrunk by 19%, while output has grown by 35%. The system discovered more efficient layouts, tighter configurations, smarter material flows. It redesigned itself from the inside, reconfiguring production lines during off-peak hours, sometimes moving entire stations over the course of weeks in incremental adjustments so subtle that reviewing daily footage shows almost no change, but comparing month to month reveals complete transformation. This isn't optimization, it's metamorphosis. And there are now 47 factories operating at this level globally, with hundreds more in transition. The combined output of these facilities represents approximately 4% of global manufacturing, but that percentage is doubling every 16 months. The exponential curve is just beginning its vertical climb. So here is the uncomfortable question we need to confront. What does it mean when factories don't need us? Not just don't need our labor, which is economically disruptive enough, but don't need our judgment, our oversight, our decision-making. For the entirety of industrial history, humans have been in the loop. We designed, we managed, we improved. Now we're watching systems that close that loop without us, that iterate and evolve on their own. I'll be direct. I don't have a neat answer to this. I don't think anyone does yet. But I desperately want to hear your thoughts. Comment below with your honest reaction. Does this represent liberation from drudgery or obsolescence? Are we witnessing the maturation of our technological offspring, or are we building our own replacement? One perspective, and it's compelling, is that these systems are simply extending human capability to its logical conclusion. We invented tools that multiply our strength, then tools that multiply our precision, now tools that multiply our intelligence. The self-learning factory is humanity's problem-solving capacity scaled and accelerated beyond biological limits. By that logic, every optimization the factory discovers, every improvement it implements, is a human achievement, just expressed through an intermediary. But there's another view, equally valid, that says we're creating entities with agency, with autonomy, with purposes that may diverge from our own. The factory's goal is efficiency, productivity, optimization, but those objectives exist in the abstract. disconnected from human welfare, human employment, human flourishing. What I know for certain is this: the transformation is irreversible. You can't uninvent this capability. The competitive advantage is too overwhelming. A company running self-learning factories will outproduce, underprice, and outlast competitors clinging to human-managed operations. Which means this approach will spread, not because of some grand plan, but through simple economic pressure. And that means we need to be having urgent conversations about adaptation, about education systems that prepare people for a world where manufacturing runs itself, about social structures that provide meaning and purpose when work no longer serves that function for millions. Here's what I need from you. If this exploration has provided value, if it's made you think differently about technology in the future, give it a like so others can find it. Share it with someone who needs to see where manufacturing is going. And most importantly, contribute to the conversation in the comments. Tell me what solutions you see, what possibilities excite you, what concerns keep you up at night. The self-learning factory isn't science fiction or distant future. It's operating right now, improving itself while we speak. Staying informed about these systems, understanding their capabilities and implications, isn't optional for anyone who wants to navigate the next decade successfully. Subscribe and turn on notifications so you don't miss the next investigation. We're tracking the technologies that are rewriting reality, and I want you along for the journey. The factories that run themselves are just the beginning. Where this leads is up to all of us. I'll see you in the next one.